Okay, we're going to rewrite each of these equations so the exponent is only t. This really goes back into this context of the previous problems we've done. The one with isotope, like t over 64, and then the one that was t over 48. And so what we're really going to do is just get this to where it's like, that's kind of weird and I don't like it, and we're going to fix it. So let's review actually some old stuff, and the old stuff is right here. If I handed you x squared and it was to the 5th power, I would really have x to the 10th. I'm just saying, okay? So if I have, if I have a power to a power, I'd multiply. So I'm going to force this to be a power to a power. Let's do it that way. That's the best way to explain it. 1/3 to the 4th to the t. That's okay. I can totally do that because this would be 4 times t, which is what I have, which is exactly what I just did. I could say 2 times 5 gives me 10. I could say 4 times t gives me 4t. But now what I'm going to do instead of making it 4t, which would be working backwards, I'm going to really do 2 times, okay, what is 1/3 to the 4th power? And we're going to do this in our head. 1 to the 4th power is 1. 3 to the 4th power is, 3 to the 4th is 81 to the t. This is equal to this. Totally the same thing. Okay, and that just takes a lot of the guesswork out of the variable with a coefficient in your exponent. Not guesswork, but eliminates that. So let's move on. We're going to do the same idea here. So a equals 1,000, 1.04, and this is to the 1/12th to the t. Okay, because 1/12 times t is t over 12, right? So we can over parenthesize if you want to. And now what I want to do is take 1.04 and raise it to the 1/12th power. Now we're going to probably run into some rounding errors here. We're not careful. So here goes. 1.04, we're going to raise it to the 1/12th. This is really the 12th root of 1.04. Right, and that's what I have. I actually am going to just write that whole thing. 1.003273774, and we're going to raise it to the t. This is equivalent to that. All right, now I want to, this is not a proof, but I want to just demonstrate that very quickly. If I typed, that's the previous problem, but if I wanted to type this in, 1,000, 1.04, and we're going to raise it to the x over 12. We'll use x instead of t. And then we'll do the same thing here, 1,000, 1.00327374, we're going to raise it to the x. I should get the same thing regardless of what I plug in. I should. And I do, okay? So you're having a hard time seeing it because of the glare here, but if I plugged in, let's delete some stuff. If I plugged in 0, which is really easy to do, then that would be my initial value of 1,000, so yeah, no surprises there. But if I plug in a 1, I get 1,003.3, 1,003.3, okay? Again, not a proof, just a demonstration. Plug in whatever, you'll get the same thing. Let's do the same thing on this one. Don't let the negative exponent throw you off. 8, 1/12th to the -2. Take another breath, to the t. And now we're going to do 8 times 1/12th to the -2. We'll do this one in our head. So y equals 8. Okay. Negative exponents move things. So this 12 is no longer in the denominator. It's now in the numerator, and it is squared. And you also have a 1, but 1 to any power is 1, so we're going to ignore that. So what I really have is 8 times 12 squared times t. Running out of room, I'll put it here. So that's 8 times 144 to the t. 8 times 12 squared to the t becomes 8 times 144 to the t. Don't do 8 times 144 because the 144 has the t. The 8 does not.